Algebra 1, Chapter 1, Section 4, the distributive property. The order of operations is what we use to evaluate any sort of expression. If it's an algebraic expression, we have to substitute values in first. But sometimes we don't have those values, but we still want to manipulate the expression that we're working with somehow. And that's where that distributive property comes in. And what the distributive property is rules on how to multiply across multiple parts of addition or subtraction. And you can see here in this little example, I got 5 times the quantity, x plus 2. Quantity is just how I tell you about parentheses. So what I have to say, 5 parentheses x plus 2 parentheses, that's descriptive of how to write it out, but it doesn't tell you about the expression itself. So 5 times the quantity, x plus 2. I know I'm multiplying everything by 5. And what's really happening here is each of the parts are being multiplied by 5. And some of the things I can multiply. 5 times 2 is 10. But I can't do anything to make 5 times x any more simple than it is, so it's just 5x plus 10. Now, I'm going to tell you, I very commonly see this. The little rainbows drawn on each thing. And that's fine if you're trying to keep track of it, particularly if it's a big thing. But the bigger it is, the more those arrows, those little rainbows you got to draw, the harder it is to keep track of them. And I have had students turn in problems that say, hey, distribute 5 times the quantity x plus 2. And they literally write down for their answer this. And they never do anything else. So I usually don't use them because I think it causes a bit of confusion. This thing with the rainbows here, that's not an answer. That's just the process. So I usually don't write them down. Sometimes I do to make one thing or something a little bit more clear. But really what I like to see is 5 times the first part here, x, in parentheses. Use the same operation, 5 times the second part, 2 in parentheses. And I just think that's much more clear. It's going to help you as you move along all the way up through geometry and algebra 2, including this class. It becomes much more clear when you're doing that instead of drawing little rainbows on a bunch of stuff. Another reason why we use the distributive property, though, is sometimes we get to problems that we don't want to do, like 5 times 47. Sure, we could just do 47 times 5, and we multiply all the stuff out. 5 times 7 is 35, carry the 3. 5 times 4 is 20, plus 3 is 235. That's the old school way of doing it. What I want to show you is that there are other ways of doing it, and it's all about using the distributive property. I'm actually going to break that 47 apart. 5 times 40 plus 7. What I've done here is I've turned it into two numbers that I can multiply a lot more easily in my head. 5 times 40 plus 5 times 7. What's 5 times 40? Well, that's just 200. What's 5 times 7? Well, that's just 35. Guess what they are when you add them together? 235. Just like we got here. Except it's not all hidden in there with numbers getting added to the top and and all this kind of craziness. It just makes things a little bit easier to do in your head. It's easier to hold 235 in your head instead of holding a 3 up there knowing that you have to add the 3 to the 20 when you're done, but really that 3 is actually a 30. That's one of the things that makes distributive property really nice. And we did that with addition there. But we could also take 5 times 47, make sure you can see it there, and 47 is also 50 minus 3, right? 5. So now I can use distributive property. 5 times 50 minus 5 times 3. You also might see that written out. plus 5 times negative 3. Either one of those works just fine. 5 times 50. 5 times 5 is 25. Slap a 0 on there. 250. 5 times negative 3 is 15. So it's minus 15. Well, what do you think 250 minus 15 is? 235. So if you've ever wondered how a math teacher can like do some really quick calculations in their head, and you're like, how do they do all of this in their head? It's because they actually use the distributive property and group things together that way. Anyways, that's a distributive property and why it's useful, and we're going to apply that to lots of other things here. This video, yeah, I got enough time to do example 1 here. Alright, distribute over addition. A group of 7 adults and 7 children are going to a University of South Florida Bulls baseball game. Use the distributive property to write and evaluate an expression for the total ticket cost. Now, when we're reading this, it's giving us some information. So I'm going to reread it now and kind of highlight some stuff. Group of 7 adults and 6 children. And they're going to some game. It doesn't matter who they're actually going to. They're going to a game. But it would be nice to know how much those tickets cost, because our ultimate goal here is to write and evaluate expression for total ticket cost. So I have to know how many tickets are going to be sold there. Luckily, when I move my video, you'll see that there's a table there. So, if I have a single adult, it's $5 per ticket. Children, it's just $3 per ticket. Now, if you have groups of 10 or more for a single game, that can actually reduce your price. But we got to figure out our expression here. So there's a couple different ways of looking at this. I've got 7 adults, and A is just what I'm going to call the cost of the adult single game, and 6 children. Now, if I didn't have a big group, you can see I got a group of 13 here, then I would just plug in the 5 for A and the 3 for C, and I would evaluate that expression. But that really doesn't use the distributive property at all. So that should be my clue that maybe this isn't the right path. If I notice I've got a group of 13 here, which is more than 10, now I know that I have the price. So I have 7 adults and 6 children, and how much do each one of those tickets cost if they have a group of 10 or more? They cost $2. So the quantity, 7 plus 6, times the price, 2. So now I'm going to use the distributive property here, 2 times 7, and 2 times 6. 2 times 7 is 14, 2 times 6 is 12, so it's going to cost $26. Oh, I should put the dollar symbol on there. Okay. So you have to pay attention. I've had plenty of people, and I've probably done it on the board too when I was brand new to this book, didn't pay close enough attention because I was going too fast. I didn't use the distributive property in this version of the problem, but it asked me to use the distributive property, so something was going on here, and that told me that this was not what I wanted to do. I had to find a way to use that distributive property. So, there we go. That's that example, and I'll continue on with more examples in the next video.